Hey 8th graders, if you are watching this, you are my blue group today and you guys will be completing lesson 2.5, Force in Motion. Obviously, if you guys take a look at this, it's quite a huge assignment. However, you are not completing all of that, so please make sure you guys follow directions that you guys see in this video and that you see throughout these slides. Okay, so first and foremost, your guys' learning target today. I can predict the correct strength and direction of force exerted on an object to change its velocity in a specific way. So everyone, no matter what color of group you are, blue, green, or purple, you guys again are my blue group, you guys should be completing slide 2, which is your warm-up. So for your warm-up, you guys have these 3 images, and then you guys have these 3 key concepts. So the first key concept says, if the same strength force is exerted on 2 objects, but the objects have different masses, the object with less mass will have a greater change in velocity. The second key concept, a stronger force can cause a greater change in velocity. And the third key concept, how an object changes velocity depends on the direction of the force exerted on that object. So what you guys are going to do is you're going to click and drag and move each of these 3 key concepts to the correct image that you guys see. So take a look at what each image kind of shows us, okay? And then again, match that with the correct key concept. Okay, remember that at any point throughout this, you guys can pause before you move on. Okay, just to double check, if you guys aren't sure whether you are the blue group or not, you guys have this link right here. So you guys can go ahead, right click, open that link up, and it should take you guys right into here. Once you guys are done checking that you are in fact blue group, okay, you guys can exit out of this. You don't need this link anymore. So you guys can go ahead, exit out right up there. Okay? All right, with that being said, you guys should circle that you are blue group so I know which slides I am correcting of yours. So you guys are going to need to take and circle blue group. Okay? With that being said, you are only completing slides 4 through 15. That includes your guys' wrap up and the last little good job, turn it in slide. So really, you guys can kind of get an idea of what you guys are watching. And again, you should have already gone in here and seen that you guys are blue group, so this is the video you're watching. Okay, with that being said, let's go ahead and move on to our assignment. So main part of this is going to be your guys' sim for today, and there's 2 parts to the sim. So first of all, your link right here to your sim, you can open that up. We'll use that here in a second. For part 1 of the sim, you're going to work together, you guys are working probably from home, to conduct a series of missions in the force and motion simulation to make objects change velocity in a specific way. The challenge will be to exert a force only one time, so we've done something similar to this before, and have it cause the velocity change you want. So what direction and what strength will the force be? So that's really what you guys need to think about as you move through these sim missions. Follow the instructions on your student sheet for each test. Again, your student sheets are included in this slide. That's kind of how I have this little line right here drawing that out. Don't forget to record your data. Again, those are in the slides. And when part 1 is complete, move on to part 2. So for part 1, here is your guys' first part of this, is to test it out. So select 2.5 blue mission number 1. So I'm going to go up here to these 3 horizontal lines. I'm going to go down to 2.5 blue mission 1. Again, you are my blue group. What you guys see in this is that you have 3 different pucks. The first thing you guys need to do is press run and record the mass of each object. So we can go ahead, hit run. And then you guys can see your mass of each object. I'm going to go ahead and hit prepare force. Mass of object A is 0.25, object B is 0.5, and object C is 1 kilogram. You guys will record that right here. Press prepare force and set up the forces to test your results. So for this one, use the force panel to set the force strength and direction for each object A, B, and C. Press exert force, observe the objects. Did they reach the targets at the requested velocity? So let's take a look at what our requested velocities are. In build, this one is 5 meters per second. If we click on that, okay, so prepare and exert a force of any size on each object to make them reach their targets with the same vertical velocity. So again, 5 meters per second, 5 meters per second, 5 meters per second. So we all want them to reach their velocity of 5 meters per second. Okay, but again, they are all different masses. So you'll hit run, you will hit prepare force, and then you guys are gonna mess with exerting different forces to get them to all run and swallow up into that little target going 5 meters per second. So if you guys look at them, they're all starting out running 1 meter per second. So you guys kind of need to figure out each one differently, and that's kind of up to you guys to decide. Okay, so with that one, mission 1, what was strength, force, and direction did you guys put on that? Remember, once you guys are done with that, you guys will be able to kind of click back and find that pink arrow where you guys exerted your force. That's going to be your guys' force strength. Remember, every time you guys click it, it should be about 10 newtons, but because these are different size pucks, you guys aren't going to be able to all hit them the same, even though they're going the same velocity now, and you want them to go the same velocity at the end. You guys are going to have to apply different forces on them, so I want you guys to think about that there. Okay, so that's what you guys will record for this one. Then you guys will go up to mission 2. Okay, here is blue mission 2. You guys have your pucks again that are all different. If you guys look at analyze, they are all going 1 centimeter per second, or centimeters per second. And you guys want them to go -7 centimeters per second. So think about this. If they're moving upwards 1, that means 7, they have to turn around and come back. So you guys have to let your little targets go past, pause them when your targets are here, and then turn them around and bring them back 7 centimeters per second. Okay, so that's going down. So you guys would do that on mission 2. On mission 3, okay, you guys are moving to the left. Let's see here for this one, you guys are going -1 centimeters per second, and you want them to hit their target going -5. Again, they're all different ones, so learn from those and then record your guys' strength and direction of each of the force you guys applied on that. Okay, moving on, after you guys fill out this data table, you guys will go on to this data table, or this part 2 of the sim here. So you're going to conduct a series of missions in the force and motion simulation to make objects with different masses change velocity in a specific way. The challenge will be to exert a force only one time and have it cause the velocity change you want. So what direction and strength will a force be? Okay, so predict what will happen first by responding to the questions. Next, again, we don't have a student sheet. Those are going to be in your slides. Follow the instructions for each test. Don't forget to record your data, and when part 2 is complete, press next and answer your guys' questions, so you'll just find your questions on the slides. Okay, so here's your prediction. First, you guys will use your draw tool to highlight the correct answer to this question, or the correct prediction rather. If you exert the same strength force on 2 objects, one with a greater mass and the other with a lesser mass, which object will reach the target first? The object with the greater, the object with the lesser, or both objects at the same time? And then finally, what should you do to make sure that both objects reach the target at the same time? What should you do to make sure, so that's just a duplicate, I don't know why that's on there. So what should you guys do? So you'll answer that question, okay? So how are you guys going to get them to hit the same target twice? And then, as you can imagine, you guys are going to be running something very similar to what you guys just did. So again, blue mission 4, 5, and 6. So you guys will have object B and object A, but they are obviously different masses. They are both stopped, but you guys will have to exert different direction forces for these. And you guys are going to try to get the target to reach them at the exact same time. So that's the only way they are going to get swallowed up, is if they hit and get there at the exact same time. So they are going to need to kind of go the same velocity, but I'm going to let you guys figure that out, okay? So that being said, you guys will complete sim mission 4, sim mission 5. Same thing, but again, you guys can see the different sizes of the pucks there. And finally, sim mission 6. Okay, so again, 2 different size pucks there. Your goal is to get them to hit the target at the same time. Okay, you guys will make sure you guys are telling me the force, strength, and direction. So with the force strength, remember you guys will need to go to analyze. You guys will buzz back to where the little force is exerted. I haven't exerted a force, so you guys don't see that little tick mark, but you should see the pink arrow with the amount of newtons, okay, in there, and that shows you guys that force strength on that pink arrow, okay? So tell me how you guys completed those submissions. Again, your goal is to make them hit the targets at the exact same time. So you really have to think about the different forces you need to apply. Then you guys will do your reflection questions right here. So you have object A with a mass of 1, object B with a mass of 4, and object C with a mass of 0.5. You exert a force on object A, and it speeds up. If object B has more mass than object A, how would the velocity of object B change if you exerted the same strength force on object B as you did on object A? So again, object B is bigger. If I put the same force on it that I just gave to object A to make it speed up, what do you guys think object B would do? Explain why. Okay. You exert a force on object A and it speeds up. Object C is half the mass of object A. What strength force would you need to exert on C to make it have the same velocity change as object A? Again, answer that one just like you guys did the last one. And finally, read this little message from Anna Gonzalez. So this kind of wraps up a little bit of our information about the space pods. You guys just did a modeling activity in activity 2.3 where we kind of assumed that maybe there was something wrong with the mass of the pods, and that's what caused, those medium strength thruster force to cause either to turn around and move the other way or to keep moving slowly and bounce off the space station. What we found out is the mass of the pod is 1,100 kilograms. That's 130 kilograms more than usual. So that can kind of narrow us down whether we're claim 1. Did it just keep moving slowly and bounce off the space station, or did it turn around and move in the opposite direction? Okay, if you guys have the same strength force, what would having an object that's heavier than normal cause the motion to do for that object? This means the pod was carrying more asteroid samples than the pods normally carry, so it is more massive. Okay, with that being said, what we're kind of bracing for is that claim number 2, where object was heavier than usual. We applied the same strength force that we always do with the thrusters, but it only slowed the pod down. It didn't stop it, and the pod kept going, and eventually what we're going to see is that it's going to hit the space station and bounce off. Okay, so now in chapter 3, we're going to start focusing in a little bit more on collisions. What happens when the pod hits the space station? Okay, finally, do your wrap up. Do you have any questions? Circle yes or no. If yes, type them below. And 4, 3, 2, 1, how do you think you did on this assignment? You guys can go ahead, hand this in. You don't have to worry about any of the other slides. You've done your part for the blue group, and I hope you guys are having a great day. I'll talk to you soon. Bye.